Hi everyone, in this video we are going to solve this double integration, but as they have mentioned, by suitable change of variables. That means we have to change the variables and then we have to solve the problem. So let us write the given integral first. What we have, I is equal to, I am calling it as I cos x minus y upon x plus y dA. As you can see here, cos x minus y upon x plus y, the function is so much complicated. If you try to solve this problem directly, it will be so much difficult. So obviously, we have to follow the instruction and we have to change the variables and then we have to solve the problem. Okay. So the most important part is the region of integration. So they have clearly mentioned, so let us mention the region of integration here, where R is bounded by, what have they mentioned? R is bounded by coordinate axis. Coordinate axis means x axis and y axis. What is equation of y axis? X is equal to 0 and equation of x axis, y is equal to 0. They have mentioned this line also, x plus y is equal to 1. So x plus y is equal to 1. So this is equation of line. So the region is bounded by these three curves, x axis, y axis and this line x plus y is equal to 1. So now we have to change the variables, that means we have to put something. Now the question is what we have to put. So we should try to find a pattern here, getting, as well as we can consider some terms which are appearing here frequently. You can see here x plus y is equal to 1. This is the equation of line. Same x plus y appearing in this denominator. So it gives the suggestion that we should put x plus y is equal to something. If we put x plus y is equal to something, obviously we should put x minus y is equal to something. So let us do the same. Let me write putting x minus y is equal to u and x plus y is equal to v. So after putting, our first task is to find its Jacobian, okay, Jacobian, and the second task to find region in UV plane, right? In xy plane, the region is bounded by these equations, x is equal to 0, y is equal to 0 and x plus y is equal to 1. See, using this substitution, you cannot find the equation directly. So for that, I am going to find the values of x and y in terms of u and v. What we have values of u and v in terms of x and y. I am going to find values of x and y in terms of u and v. So for that, I am calling it as equation number 1. This is equation number 2. See, in our school days, we have already seen how to solve such simultaneous equations. There is one obvious method, adding two equations, subtracting two equations, multiply first equation by something, second by something, add them, subtract them, right? So same thing I am going to do here. So what do you think what we need to do to find the values of x and y? As you can see here, we have a minus y, we have a plus y. So if you add them, minus y plus y will get cancelled, y will be eliminated and we can find a value of x. I am going to do the same. So let me mention adding 1 and 2. Okay, so let us see what will happen if you add these two equations. I am going to add directly here. Directly, that means I am going to write it directly. X plus x, 2x minus y plus y will get cancelled to each other. And this is equal to the right hand side also will be added and we will have u plus v. See, we got the value of 2x, but what we want actually, we want the value of x. So that's why I will divide both sides by 2. Dividing by 2, so 2 will get cancelled. Dividing by 2, so u by 2 plus v by 2. So in this way, I got the value of x in terms of u and v. Let me highlight it, okay. So now what will I do? I am going to subtract, getting? You can either subtract or you can put a value of x in one of these two equations. So I am going to put that value of x here. Let us see what will happen. Putting value of x in equation 2. Let us see what will happen. Here I am going to put x is equal to what? U by 2 plus v by 2. Y as it is equal to v. So y as it is, I am going to find a value of phi. So let us shift all remaining terms on that side. So y is equal to, see, v minus, see, u by 2. Here we have a plus sign. If you shift it there, we'll have the minus sign. So this is equal to, y is equal to, so minus u by 2 as it is, v minus v by 2, that is v by 2. So I got the value of y also. Got the value of y. So finally I got the value of x and y. So the next task is to find a value of Jacobian. Okay, so let us find Jacobian. Where shall I write? Let me write here. Then Jacobian, its formula is derivative of x with respect to u, derivative of x with respect to v, derivative of y with respect to u, derivative of y with respect to v. So here I will show you how to find derivative. Okay. So I will show you few of them. So derivative of x with respect to u. So what is our x? Our x is this u by 2 plus v by 2. As addition is there, you can take separate derivatives, right? So derivative of what? U by 2 plus derivative of v by 2. So that 1 by 2 is constant, no? It will come outside. That 1 by 2 will come outside. Derivative of u, and see, we are differentiating with respect to u. So v is constant. V is constant, that 2 is also constant. We have this constant term, so derivative of constant term is always 0. This is equal to half derivative of u with respect to u, which is 1. So the answer is half. Okay, so let me write directly here. So this is equal to half derivative of x with respect to v. Okay, in the same way we can find, and its value will be half. So I am writing directly. So my suggestion is, if you are not much comfortable with the derivative directly, then solve it separately and then we can put the value here. I am writing this time directly. In the same way we can find all remaining 3 derivatives, right? Okay, so let us find derivative of this y with respect to u. I will show you one more, how to find derivative of y with respect to u. Addition is there, we can take separate derivatives, okay? So minus u by 2 plus derivative of v by 2. What is constant? Minus 1 by 2 is constant, will come outside, derivative of u only. See, here v is constant. Since we are differentiating with respect to u, so it's constant, this is also constant, derivative of constant is 0. Minus 1 by 2, derivative of u with respect to u 1, so it's minus 1 by 2. So I got its derivative minus 1 by 2. In the same way we can find derivative of y with respect to v, which will be 1 by 2. So finally we got all derivatives. Let us find the value of determinant, okay? Yes, you know that how to find determinant, this one into this one, so 1 by 2 into 1 by 2 minus product of these two terms. So it's minus 1 by 2 into 1 by 2. 1 into 1, 1, 2 into 2, 4. Minus minus plus 1 by 2 into 1 by 2, 1 by 4. Both of them have same determinant. So we can add numerators. So 1 plus 1, 2. So 2 by 4, which is 1 by 2. So I got the value of Jacobian. Okay. So Jacobian we got. Now we have to find its equations. Okay, we have these curves, so we have to find their equations in UV plane. Let us see what will happen in UV plane. Just make a screenshot of it, then we will go further. So let me mention, in UV plane region is bounded by, in UV plane region is bounded by, what is the first equation? X is equal to 0. You remember na, coordinate axis first equation is x is equal to 0, y axis. X is this one, so you can write u by 2 plus v by 2 is equal to 0. What will I do? I will multiply both sides by 2. So 2 will get cancelled, this 2 also will get cancelled, and 2 into 0, 0. So I got the first equation, u plus v is equal to 0. What is second equation we have? y is equal to 0. So let us put the value of y. Minus u by 2 plus v by 2 is equal to 0. Same technique we can apply. I'm going to multiply both sides by 2. So this 2 will get cancelled. Minus u plus v is equal to 0. In a simple way we can write by shifting u on that side, v is equal to u. And last equation, what is last equation? X plus y is equal to 1. So x plus y is nothing but our v, right? So we can write v is equal to 1. So in this way I got all these three equations. Okay, just make a screenshot of it, then we will go further. So let us draw those curves in uv plane. Okay, so u plus v is equal to 0. Power of u is 1, power of v is also 1. It represents a straight line. So in case of straight line, what we do, we draw table like this. Okay, so the first is u, second is v, the next one is u comma v. So what we have to do, we have to find any 2 points on the line, get it? So by joining them we get a straight line. I am putting u is equal to 0. If I put u is equal to 0, v will be 0. So the point is 0 comma 0. If I put u is equal to 1, by shifting 1 on that side, value of v will be minus 1. So point is 1 comma minus 1. So let us plot those points on that uv plane. 0, 0, obviously it is here. u1 and v minus 1, u1, v minus 1 here. So by joining these 2 points, we get this line. The equation of this line is u plus v is equal to 0 or v is equal to minus u, right? V is equal to u, this is also a line. So I need to draw one table. So in this table, what we do, we find any 2 points on the line. By joining them, we get a straight line. U, V, U, V. I am putting u is equal to 0. So v will be 0, point is 0, 0. I am putting u is equal to 1. Any point you can put, getting no restriction on that. You can put any, it's your choice. So I am putting u is equal to 1, so v will be 1. So the point is 1 comma 1. 0, 0 is here and 1, 1 is here. So let us join them. Okay, so I got this line. Okay, so this is v is equal to u or u is equal to v. The last one is v is equal to 1. We know that it's a line parallel to u axis, passes through v is equal to 1. So this is a line v is equal to 1. So region is bounded by these 3 lines. Okay, so what will I do? I am going to consider a strip here which is parallel to u axis. Okay, we have to find the limits, no? So we need to consider a strip here. We have 2 choices. We can consider a strip parallel to v axis or parallel to u axis. It is better to consider a horizontal strip. If you consider a vertical strip, then problem will be difficult. We need to divide region in 2 parts. It will be complicated. Okay, so that's why I'm going to consider a horizontal strip. So strip is parallel to u axis. So we should write u varies from. First, u varies from u is equal to u is equal to, and then v varies from v is equal to v is equal to. See why I am writing u first, since my strip is parallel to u axis. So that's why I am writing u first and then I am writing v later. So strip is like this. This is its base, this is its top, right? So strip is bounded below by this line whose equation is u plus v is 0. But we want u is equal to, so let us shift v on that side. So u is equal to minus v. The strip is bounded above by this line, getting this line whose equation is v is equal to u. That means u is equal to v. V varies from, see we have strip like this. Now we have to move strip from bottom to top like this. It will start at bottom, slowly it will move like this and it will go to the top of the region to cover each and every corner of that region. So strip will start here where the value of v is 0. It will move like this and it will go up to this line where the value of v is 1. So in this way I got the limits. So let us write I is equal to, strip is parallel to u axis. So I should write du first and next dv. So what is the function we have? Cos. This is our u, x minus y is our u. We have already substituted, and this is our v. Mod z also I should write. Z means Jacobian. Limits of u first, minus v to v, and limits of v 0 to 1. So value of Jacobian is half. We have to take mod, but number is already positive. If you apply mod, you will get same. That 1 by 2 I am taking outside, 1 by 2, 0 to 1, minus v to v, cos u by v du first and then dv. Okay, we are going to solve this integration. Just make a screenshot of it, then we will go further. So let us solve this integral further. Okay, so I is equal to half 0 to 1. So did you notice one thing? The limits are minus v to v. So there is one popular result when you have limits like this, minus a to a, f. If the function is even, f is even. If the function is even, we can write 2, 0 to a, f. Getting? So if the function is even, we can write 2 further and you can change the limits. If f is odd, if the function is odd, the value of integral is 0. So cos is an even function and sine is an odd function. So cos is even. So that's why what I should do, I should write 2 first. Okay, so let me do here. So let me write here 2. I am writing that 2 here. Limits 0 to v. Limit will be changed according to that formula. And cos u by v du and then dv. Okay, so that formula I use. Let me remove that part. This one also and this one also. Okay. Yes. So let us integrate. This 2 will get cancelled. Okay. 0 to 1. Integration of cos is sine u by v. But what we do, whatever the multiple of u we write in denominator. Here multiple of u is 1 by v. So I should write in denominator 1 by v with limit 0 to v dv. That 1 by v is constant will come outside, and one more thing, that v is in denominator of denominator. So it will go to the numerator. So that v will appear here. Okay. Sine u by v 0 to v dv. So let us put upper limit, lower limit. Let us see what will happen. Sine, at a place of u, I am going to put v by v, minus sine, I am going to put 0. So 0 will have dv. Let us solve it here. So this is equal to 0 to 1 v. 1 vv will get cancelled and we will have sine 1. Sine 1 minus sine 0 is 0. See, we don't know the value of sine 1 and basically it is a constant. So it will come outside the integration. Sine 1 will come outside. V is there. Its integration is v square by 2, 0 to 1. So this is sine 1. I am putting upper limit 1 by 2. Lower limit 0. So 1 by 2 into 0 minus 0, 1 by 2. If you take the product, the value will be sine 1 by 2. So this is required answer. Okay. So make a screenshot of it. Then we will stop. Thank you. See you.